Hi, my name is Paris, and today I'll be walking you through the design of my Pac-Man game system, focusing on the use case diagram, sequence diagram, and class diagram. These diagrams illustrate how the system is structured and how it operates according to the object-oriented principles. Let's start with the use case diagram, which focuses on the specific scenario of each ghost. In this scenario, the primary actor is a player who interacts directly with the Pac-Man game system. The player's goal is to increase their score by guiding Pac-Man to eat a ghost. For this to happen, several preconditions must be met. The game must be in progress, Pac-Man must have consumed a power pellet, and at least one ghost must be in frightened mode. Once these conditions are met, the players navigate Pac-Man through the maze towards a ghost. Upon collision, the game system detects the event, allowing Pac-Man to eat the ghost, which results in an increase in the player's score. The ghost then returns to its starting position, and the game continues. This use case illustrates a core interaction between the player and the game system during the ghost eating scenario. Additionally, the diagram considers extensions to this scenario. For example, if Pac-Man does not collide with the ghost while in frightened mode, the ghost will eventually revert to their scatter or chase modes, and Pac-Man will no longer be able to eat them until another power pellet is consumed. Another extension covers what happens if Pac-Man collides with a ghost outside of frightened mode, resulting in Pac-Man losing a life and all entities returning to their starting positions. Next, let's examine the sequence diagram, which depicts the flow of events in this scenario where the player loses a game of Pac-Man. This diagram provides a step-by-step visualization of the interactions between the player and the game system. The sequence begins with the player starting the game, prompting the game system to place Pac-Man and the ghosts in their respective starting positions. As the game progresses, the player directs Pac-Man to move through the maze using the arrow keys, while the game system simultaneously manages the movements of the ghost based on the behavior modes, either scatter or chase. The sequence diagram is particularly valuable in illustrating how the system detects collisions between Pac-Man and a ghost. Upon detecting a collision, the game system updates the player's lives, decrementing the life count by 1. This process of moving Pac-Man, managing ghost behavior, and checking the collisions continues until Pac-Man loses all lives. At this point, the game system ends the game, signaling the player's defeat. This diagram is crucial for understanding the dynamic interactions within the game and how the system responds to the player's actions over time. Finally, let's discuss the class diagram, which provides a detailed look at the static structure of the Pac-Man game system. At the heart of this design is the game system class, which orchestrates the overall game flow and manages interactions between various components, including Pac-Man, Ghost, Maze, and Score Manager. The Pac-Man and Ghost classes are associated with the game system, meaning that the system controls their behavior throughout the game. For instance, Pac-Man is responsible for tracking its position, lives, and speed, while Ghost manages its position and behavior modes. The game system also has composition relationships with the Maze and Score Manager classes, indicating that these components are integral to the system. The Maze class, for example, is responsible for representing the game's environment, including the layout of walls and the placement of pellets. The maze itself is composed of wall objects, which define the boundaries and obstacles within the game. The maze also interacts with the position objects to track the location of elements within the grid. Meanwhile, the Score Manager class handles the tracking and updating of the player's score, ensuring that the points are added when Pac-Man eats pellets or ghosts. This class diagram not only illustrates the relationship between these classes, but also reflects key object-oriented principles, such as encapsulation, where each class manages its own state and behavior and has solid principles, which ensure that the system remains modular, maintainable, and scalable. In conclusion, the UML diagrams presented here, use case, sequence, and class, collectively provide a comprehensive view of the Pac-Man game system, from the player's interactions with the system to the internal structure and behavior of its components. These diagrams illustrate how the system is designed to be robust and flexible. By adhering to the object-oriented design principles, this system is not only capable of handling the current game requirements, but is also designed to accommodate future enhancements with minimal disruption. Thank you for watching this presentation, and I hope it has provided you with a clear understanding of the design and architecture of my Pac-Man game system.